today, if I can have your attention this way, everybody. So last time's class, we reviewed what we had learned the prior unit in terms of going from like gram to mole, liter to mole, and then we kind of introduced a new concept of going mole to mole. Remember, the big part of going from mole to mole is the fact that now we're actually dealing with a chemical equation and things are actually changing, right? Where it's actually converting, reacting, making something new. When last unit was really just about how many moles are in this pile that I have here, okay? Today, if last time's lesson and the warm-up today was like, made sense, today's lesson is just putting it all together. It's actually, each of the steps individually are the steps you've already done. The difference now is we're just gonna put it together into actually more practicality of how chemists use stoichiometry. So these are the basic steps for any stoichiometric problem. Once again, keep in mind, stoichiometry is just our fancy word from going from one substance to another. It can be as simple as saying, all right, I want to make 48 cookies. How much flour do I need? That's stoichiometry. It's just in a chemical reaction, how much of this do I need if I want to make this much, or vice versa. Okay? So first step is to always identify the units of what you're trying to find and the units of what you know. So I'm going to follow the pattern we did last time, where when I read a question, I'm going to underline what I know, and I'm going to circle what I'm trying to find. And I would encourage you in your notes and on your homework to do the same, because that helps you really keep track of, okay, where am I headed and where am I going? We're going to be using something, or you can use it as a tool, and it will be there for you even on the quiz if you want it, of a map that can help you identify how many steps it's going to take. And I'll show you that map here in a second. Okay, we will always need a balanced equation. Oh, she knew she had her appointment. She just went down. I don't know if she'll come back. I think she got it at 8. There you go. So you're always going to need a balanced equation. So unlike when Ice noticed with number 4 from our warm-up, I thought the balanced equation really wasn't needed. All the problems here now are going to need one, so if it's not given or it's not balanced yet, like it just has blanks, make sure you balance it first. Okay? Then we'll set up our conversion map, which is what we'll practice today over and over again. Okay? All right, is everybody good there if I go to our next slide? All right, so this right here is our conversion map that helps us identify how the different units are connected. Once again, you've done all of these just in one step. You've done liters to moles, right? So every time you cross an arrow, that's one step, okay? We've done moles to moles, right? So you've done this before, and you've done moles to grams. The difference is now we're going to be doing it in one process, so you're going to have multiple fractions set up side by side. So hopefully the goal today is that it just feels longer, but it doesn't actually feel harder. It just takes a little bit longer to get through. Okay? Now, once again, this map is on your table. I've given one to each side. I think I got everyone. Did everyone get one? I'll give you a kind of picture on the side here. Okay? And you'll be given this on the quiz. So this will be a resource to you if you find it helpful. Okay? All right, so let's take a look at the first problem together and watch how we use our map. Okay? So the first thing we're going to do, I'm going to pull it down here so I can circle and underline with you. Okay? So grab 2 colored highlighters for me. Well, I guess in the end you might need more than 2, but start with 2. I'm going to start with red and blue, so if you want to use blue and pink to match, but once again, it doesn't really matter as long as you follow the pattern. Alright, so first thing I want to do here is I want to underline what the problem gives me, like what do I know about this, and then circle what is it I'm trying to find. Keep in mind, you want to identify unit and label. So the problem says how many moles of potassium chlorate, so I'm going to circle this whole thing here, so circle this with me, moles of potassium chlorate, which it tells me is our KClO3. Okay, that is what I'm trying to find. That should be the last thing I get to, because that's what we're trying to solve for. Are required to produce 2.0 liters of oxygen gas. So I'm going to underline what do I know. so then what I do, oh, actually, I want to cut it. I just want to copy you. I'm going to bring it a small one over here so we can talk about it. Okay, that will do. I'll grab my stick. Okay, so once you have circled and underlined, then the next step that is very helpful is to kind of see where am I starting and where am I going. So then you kind of get a clear picture even before you start writing. So what is it the unit that I'm starting in?
Leader.
Thanks, Taylor. So I'm starting the unit of a liter. So if you put your finger, everybody, on your map, this is the box I'm starting in. Notice you're always going to start somewhere in this side. In this case, I'm starting here. Liters of something I know. I know I have 2 liters of oxygen. What is the unit I'm trying to get to? Of what? Oxygen, so something different. So my ending box is moles of an unknown because it's a new substance. So in the end, this problem's going to take us 1, 2 steps. There's no airplanes here. You have to follow the roads. Okay, everyone kind of see how that map is matching up here? Okay, so if you want to draw arrows to match your steps, I'll show you how you can do that. Okay, so the first thing, just like before, let's write what we know down. Where'd my markers go? Okay. All right, so put 2.0 liters of oxygen gas, which is O2. Right, I can find that in my equation. That oxygen is just pure oxygen, but it always comes in pairs. Okay. I'm going to set up my first fraction here. I'm actually going to do this with the map so I can write on it. Sorry, I keep changing my mind. Okay, it's small, but I think of it the idea. Okay, what unit should always go on the bottom? The unit you're coming from, right? So wherever you're starting, so liter of O2 should go on the bottom. Now, coming to my map, I'm starting here, and I'm ending here. So my first step is I have to change my liters of my substance into moles of that same substance. So my next step, I'm going to change color because I'm changing unit. So now I need to go to moles of O2. Okay, so I had to go from liters of O2 to moles of O2. Now I'm going to keep building my map, and then I like to come back for the numbers after, because that's just the way my brain wants to flow to the end before I go. Okay, so I'm going to set up my next step here. The unit I'm trying to leave should go on the bottom, so I'm going to put moles of O2 on the bottom. Now, looking at my map here, right, I'm in moles of O2. Now I'm traveling to moles of unknown, so I can put mole of KClO3. All right, things to notice with our patterns. Once again, notice the diagonals, right? Liter of O2, liter of O2. Mole of O2, mole of O2. The only unit that doesn't have a match is the unit that you circled. Because that means you've gotten to a more step. Okay? All right, questions so far where something came from? All right, another thing I want to point out. In this step, bring your eyes up here really quick, everybody. In this step, the units are different, right? A mole and a liter. If the units are different, the label must be the same, because otherwise there's not a connection. If the unit is both mole, then the label can be different, because the moles can connect anything, right? The grams to liters, that's a much harder connection for substances, right? Like, how many elephants in grams are how many liters of elephants? But moles, I can compare moles of elephants to moles of penguins, because it's just a counting number. It's just like a dozen, right? I can have a dozen penguins, I can have a dozen donuts, I can have a dozen of anything, so just like that is the mole, okay? All right, so now for my numbers, the numbers are what make the fraction equivalent. So liter to mole relationship, which actually the map gives you hints there too. What connects liters to moles of a substance? 22.4. Now should that go, point with your finger, should that go on the top or on the bottom of this fraction? Point through your finger where I should put that 22.4. You're pointing down, have a smiley face, good job. Right, because there's 22.4 liters in 1 mole. Okay? The mole to mole bridge is what comes from the balanced equation every time. So the balanced equation tells me I have 2 KClO3s for every 3 O2s. Questions on that before we plug it in? Here's how I would choose to type it in my calculator. Right? Make sure you always start at the left. I would type in 2. I ignore number 1s because they do nothing mathematically. So I'm going to do 2. I'm going to hit divide by 22.4. I'm then going to times by 2 and divide by 3. That's how I choose to plug it in. I don't like to type in fractions. So I just divide. If it's on the top, I hit times. If it's on the bottom, I hit divide. If it's a number 1, I just ignore it. Try typing that in and let's see if we can all get the same answer. That's the worst part, is if you have the right setup but are getting the wrong answer, that's a sad place to be. All right, you get 0.06 moles KClO3. Have a smiley face. Any questions so far? Hopefully we're seeing like the blend of what we did last time and connecting it to this time. We'll do some more problems, but any questions so far? Okay, before I do another one, for another smiley face, I want you to have a quick table discussion. Okay? With your table, I want you to talk about, what does this answer mean? Like, it's great if you can do the setup, but we need to also have the big picture perspective of like, what do our answers represent? Okay, so I'll give you 1 minute and then we'll randomly call on some table and someone will have to share about what they think this number represents. Okay, any questions on what you're discussing as a table? Okay, so discuss as a table, what does this represent? And then we'll randomly pick a few to share. Ready, set, go. Turn on our lights. What is that? What is that telling us about our problem? Put it into a sentence, maybe.
I got scissors.
Sorry. That's how much you need.
I got like
Okay, here we go, ready? So I'm going to call out a random element. So look at your element on your desk. Okay? If I call on you, you are always allowed, remember to, 1, you discuss at the table so you can share what somebody else said. It doesn't have to be your own, just give them credit. 2, you could ask a question if you feel like you don't know how to answer it instead, but a question to help you get to the answer. Okay? All right, look at your desk. Who has element sodium? I didn't check if they're here too. Na is your symbol. Na, sodium. It's just 1%. Is that Desmond?
Yeah.
Oh, it's Paisley? Paisley, the chosen one. Okay, Paisley, so what do you guys think? From what you discussed, can you put this into a sentence, or what does this represent for us?
Can I ask a question?
Totally, ask your question.
What does it mean?
Great question.
I don't know.
Great question. So, going back to the question said, how many moles of potassium chlorate are required to produce 2.0 liters? So what this is telling me, everybody, is it's telling us if I want to make this much oxygen, I need to start with this much potassium chlorate. So this would be like if I'm like in a lab setting, I'm like, okay, I need 2 liters of oxygen, then I would want to start with this many moles of potassium chlorate, and it would make for me my 2 liters of oxygen. Does that make sense? Nod your head yes or no, everybody. Okay, awesome. Because notice there's 2 parts to this I can't, right? So on the quiz, yes, you need to know how to solve them, but the second part of the I can is I can understand the answer, right? I want it to have meaning to us and not just be this alphabet number soup on the page. Okay? All right, any questions so far? Paisley, have a smiley face. That's a great question. Okay, we're going to go out of order here in our notes really quick. Everybody flip the page and we're going to skip to number 4. And we'll come back to the other ones here. But come to number 4 with me.
What's copper?
Okay. So the reason we're skipping is I'm going to do this reaction for us as a demonstration, once again, to try to bring these things to life. So I just want to skip to this one here. Okay. Okay, I'm going to walk through it again. Follow along. I'm going to go a little quicker than last time, but stop me if you have any questions. Okay? All right, first step. Identify what do I know and what am I trying to find. So it says how many liters of carbon dioxide, so I'm going to circle that again, that's my goal. Right, so how many liters of carbon dioxide gas are produced with 50 grams of water? Okay, so this question is saying, all right, if this much water was made when I did the reaction, how much of this was made, right? How much of my other product is there too? Okay? All right, don't say anything out loud, but I want you to look at your math and then hold up on your fingers for me. How many steps do you think this problem is going to take us? Don't say anything out loud, just look at your map and then hold up on your fingers how many steps it's going to take us. So we're starting in grams of something. We're ending in liters of an unknown. So if you said 1, 2, 3, have a smiley face. So once again, notice I just put stars where I had circled and underlined, and then you just have to connect the lines. All right, so I'm going to start with what I know. 50 grams of H2O. Write this down here, everybody. Set up my first step. Some students even, they like to draw all their steps blank just once they know it's 3 steps. So some students would do this and be like, all right, I know it's going to be 3 steps. And so they just go like this once they know that from the start. You want to do that? Great. Okay? All right, now take it step by step. The first step is to go from grams of my known to moles of the known. So that means I'm going to go from grams of H2O into moles of H2O. Well done. Okay. Once again, notice the color pattern here. I'm going to keep going. So the the next step is to go out of moles of water, right? The bottom of the fraction is the box I'm leaving. I'm leaving moles of water, and I'm trying to get to, what's the next one I'm trying to get to? Yeah, moles of my CO2. I need another color here. Okay. All right, final step. I'm leaving moles of CO2. And I'm trying to change that into what unit? Liters of CO2. Once again, the only piece where the labels can be different is the mole bridge. Okay? All right, questions on my setup before we plug in numbers? Now, each of these fractions, even though they're connected, what goes in here has nothing to do with what's on the left or the right. It's just what makes those two things equal to each other. Okay, so how do I make moles and grams equal? Where do I look? Go to the periodic table. Thanks, Caleb. And so I find the mass of water, which some of you might have memorized because we found it a few times now. Yep, 18.02. So 18.02 grams for every 1 mole of water. All right, once again, read it as a sentence. There's 18.02 grams in 1 mole. Okay, mole to mole, where do I find that relationship? Balanced equation. So water is 4, CO2 is 3. Mole to liter is connected through what? 22.4 to what? And then your calculator can do the heavy work of solving it. Questions on my setup or my numbers or anything like that? All right, here's how I would choose to type it in if you need help with that. So I do 50, I divide by 18.02, I would times by 3, I would divide by 4, and then I would times by 22.4.
So you take 2 of the hydrogens and multiply it by oxygen.
All right, if you type it in correctly, you should get, I got 46.61.
What do you mean? I got
Did that same answer? 46.61.
I'm just drawing more.
2 decibels is what you'll get. It should give you the same thing. Yep. Do you have a different mass than me? Oh, if you round it as you went, yeah, but it should work out the same stuff as here. Yeah. Oh, you got it? All right, any questions on our setup? I have a calculator. Yeah, they do. Phone, for how good phones are, at least Apple, their calculators are not good. Okay, any questions? Do this for me, everybody, since there's no questions. All right, take your hand for me, everybody. Give me a fist. Give me a fist. Give me a fist, everybody. Now close your eyes so you're not influenced by others. Okay, on a scale of 1 to 5, how are you feeling about, like, starting the homework? 5 is I'm ready to go. 1 is I need more help on the board. All right, hands down. So it looks like most of us are feeling pretty good. Some of us who maybe missed a little bit of the lesson might want a little bit more help, so I'll come around and just help you as needed. Before we do that, let me just do this as a demonstration because I almost forgot. Hayden, because I trust you, will you come up here and help me? Okay, so you know how to light a match?
Propane gas. Yeah.
Stand like arms away. It will be hot. Okay, everybody, eyes up here really quick, and then we'll have a good amount of time to work on our homework. I just want to once again bring these letters and numbers to life. Okay, so we're going to do this actual reaction. So I have some propane gas. Okay, I'm going to combine it with oxygen. Similar to last time, the oxygen is just going to be the oxygen in the air. Okay, and it's going to make CO2 and water. Now, it's a cool demonstration, but once again, to keep our bridge here of what we see with our eyes and what we can't see, okay, you're going to see the reaction take place. Something will happen. What you're not going to actually see, though, is you're going to kind of see this because I'm going to trap it in bubbles because it's just a clear gas, so you can't really see it. So I'm going to put it inside bubbles so you can see that it's being made. Okay, the oxygen we can't really see, but we know it's there. These, you're also actually not going to see them when they're done because they're going to be, the water is going to be in a gas form, and CO2 is always a gas. So we're dealing with a lot of gases here, but you're going to see evidence that a chemical reaction took place. Okay? Now, in terms of our stoichiometry, how this could apply, once again, is our question said, how much of this is made if 50 grams of water? So if I were to do this reaction in a controlled way to catch the water when it was made, if it measured out to be 50 grams, then we know we should have made 46 liters. Okay? All right. So right now, so this is just soapy water right here. I think I added enough soap. It's hooked up to my gas line, so I'm going to pump the gas into it to create my bubbles. Okay? Some reactions, as we'll learn in our next unit, need a kickstart to happen. Like our magnesium last time, right? Like it didn't go, and so we're also going to use flame to kickstart this reaction. You can look at it this time.
Kate, you're late.
Wait, you're pretty late.
Kate, you're really late.
Actually, Kate is fast.
Okay. Alright, so this is my weird contraption to make bubbles. So the bubbles right now are being filled with our gas. Okay, so get a good build up here. I'm going to get my hands wet and soapy. Oh, I got a good ratio. If you get the right density, then you can see it actually goes up because it's lighter than air, so they do like somewhat float. Okay, Hayden, are you ready? You ready? So couldn't see the gases, but the fire, that's the evidence of the chemical reaction taking place.
Can you do it again?
Can we try?
Can we do it again?
Yeah.
Okay, we can do. I'm not gonna let you try right now, but
Right now.
How do we try
Yes.
5 times 10.
Can you put the bubbles on like a case? Exactly.
now
This one's not.
it is quite hot. Anyone know why I don't get burned? Yeah, because water actually is a pretty good heat protectant, and because it burns so quickly, since my arms are wet and soapy, it's protected actually from getting burned. If it burns slowly, I'd be in trouble because then all the water would evaporate, right? But like water does a good job at like keeping keeping the heat off my skin, so. Oh, like it feels warm in my hands, but it's not like burning me at all. So. So the real reason is because I'm actually
20 points off presentation. You're pretty late.
okay. It's probably one of my favorite demonstrations. One year, when I taught at Lehigh High School before Skyridge opened up, and one year we had this really cool company do our school pictures, and they let us like do it with props, and I held fire in my picture, like my school picture. Yes, let me say one thing I found. Okay, today's homework is the page that says 2 and 3 step, but it's only the front side is due next time. Okay, because I know these ones take a little bit more, so you don't have to do the back today. It's just the front side, so what is that, 6 questions? Right, so homework is just those 6 questions. If you get that stamp today, then you don't have to turn it in online. Okay? All right, use our time wisely. I'll come around and help as needed. If you need a calculator or anything else, let me know. Oh, let me stop that. So let's use our time wisely.